for people who are not. So for people who are not here, the exam next week will appear in Moodle, and you will have a link to view the exam, to submit your responses, and your multiple choice responses, because it will be a multiple choice exam, and then a link to upload your solution step by step, and it must be handwritten. Okay, you just follow the instructions, and you will find the test in the top here. I'll put it up at the top of the platform. All right, so any questions about any of the modules before we get to regression?
Profesora,
Sí.
el sábado que viene, el 27, tenemos reunión, o sea, tenemos clase.
We will have class next week. I didn't put it today. We will have class next week, and then we will break. At 1 o'clock, the test will appear on the platform. So there will be class. Again, you don't have to attend, but you should attend 5 classes to get your participation points, right?
We can see the scores of the classes that we attend.
Yeah, I'm going to put the scores up. I haven't put it yet. Yeah, so then you can see your performance, or your, I guess, yeah, performance. That's the right way to say it. Those will be up today. So you have some feedback. Okay, so any questions about the modules so far? Nothing? Wow. Should we discuss regression and then go back and solve some exercises together? Or do you want to solve exercises first and then go to regression? Who votes for solve some, like, we can solve some old exam problems together for the modules?
I vote for that one.
Of all topics, or we wait for regression?
Normal distribution and then regression.
Okay. How about, let's see the chat. Any comments about that? You can put it in the chat. So do you want to do a review of regression first? Or do you want to just start, we can solve some old problems together? Okay, so I can, okay, good. So we'll, okay, so let's resolve some, sorry, let's solve some problems, and I'll include some normal, some regression, and you can have an idea where you have a lack of understanding, and then we can go into regression. Oh, problems, okay. All right, so let's see. Should I do the review exercises online, or do you want extra problems? So review exercises online are found in here. You want the review, or you want something extra? Okay. Okay, the Amari asked for regression quizzes. Let's start with the regression quizzes, and then we'll go to the online review. Okay, so let's see here. Which one, Naisha? Oh, no, sorry, Damaris.
I think it's on the quiz 5.2. I had a question. I'm trying to open the specific thing to see the question that I had. It's number 2. I had a question on that one.
Number 2. Can the amount of carbohydrates, this one?
Yes, that one.
Okay. Can the amount of carbohydrates in a breakfast cereal be predicted from the amount of sugar in the cereal? Carbohydrates in grams per serving and sugar content in grams per serving are recorded for 10 Kellogg's breakfast cereals. The correlation is 0.895. So this is the regression here. This is the intercept. This is the slope. This is X, sugar is X, and sugar is Y. Sorry, carbohydrates is Y. So let's go find the true one. For every additional gram of sugar per serving, we predict an increase of carbohydrates. So what's wrong with the statement?
That is the opposite, right? Will
Yeah,
be a-
because there's a negative here, it's the opposite. So that's not right. Good. Adding more sugar to cereal causes carbohydrates to decrease. What's wrong with this one?
That's the one that I.
Okay, this one, cause is the problem. You cannot say it caused.
The cost.
I mean, we feel like it caused, you know,
Okay, I see.
but we think
Part.
that, but that's, you can't prove that it causes carbohydrates to decrease. It looks like there's a relationship, correlation, but correlation does not mean causation. That's, you need extra information for that.
Mhm.
Okay. And sometimes the theory, if there's theory behind the regression, you can actually say that. In economics, econometrics, we do that. We say, oh, well, there's so much theory. We know that market forces influence the returns for a stock on the stock market. So you can say it causes, but not here. There's no other evidence here provided. If you're a biology student and you're reading this, or you know something about biochemistry and you know that that's not written here, so you can't, it would have to state it clearly that one causes the other, but it doesn't. So that is not true. Let's continue. Regression on sugar content accounts for 89.5% of variation in carbohydrates. What's wrong with this one? So they're giving the number of the coefficient, but this is not the interpretation of the coefficient. This is the interpretation of the coefficient of determination. Remember R square. This is the interpretation for R square. So that's not correct. That's what's wrong with that. The only way how do we interpret the correlation? How should we interpret this one? What does correlation mean? It's an index, and the closer the index is to 1, the stronger the relationship. So this indicates a strong relationship in sugar content and carbohydrates. That's the interpretation. This, you will have to square it, and whatever number you square, you can put in this sentence. But 89.5% is not correct. Also, clearly, this is not a percentage, okay? R is not a percentage. R is an index with no units. It's just a value between -1 and 1. But when you square it, this is the interpretation. Look, they have the wrong number here, though. Every time you square a decimal, it's going to be smaller. So 0.895 square is 80. So it should say regression on sugar content accounts for 80% of the variation in carbohydrates. And it's actually backwards. Wait, it's because usually you say y, the variation. Oh yeah, it's okay. Just that this has to be squared. All right, the next one. Is that okay, Naisha? You got that? So this is r, not r square. R square goes in this sentence. They put the wrong number. Let me show you in the notes where that is. Let me open another. I'll open another. Okay, so these are the notes. And this discussion is here. Let me talk a little bit about the notes too, because it looks like there's a lot of notes, but really there is not. So this is the discussion on R square right here. It answers, so I presented this material with 9 questions. You should be able to answer all 9 questions to be able to, perform well on the exam. I added some other material to answer this question, but I'm not going to test you on that. I'm just going to test you on these here. And for completeness, I added extra notes. I've done that here, and I do that also in the last module. But that's all I want you to answer. So the last question, that what proportion of variation in y is explained by x? In other words, what is r square? So when you take r and you square it, you calculate what's called the coefficient of determination, and it indicates the proportion of the variation in y that's explained by x. So it's the last thing that I taught you here. And after that, I have these extra notes that you don't have to study or worry about. It's there for completeness and for economics students to review what they've learned in economics, but I don't test you on that. And it's a specific application of the regression. And then I start the notes again here on this is page 19. So you can omit the other pages. And then they're just problems. The rest of the notes are just exercises. So really there's only 10 pages in the notes. Let me see, I think it's 10 pages. Like 9 pages. So regression is very short. For people who haven't started regression, it's very short. And the main thing is to know how to use your calculator to get the statistics out and how to interpret the results. All right, so let's get back to the quiz. So these are all wrong so far. Let's go to D. A good prediction of the carbohydrate content of a cereal with 24 grams of sugar per serving is 2.448 grams. So what you need to do is to take 24 and put it here and multiply and subtract from this and see if you get this number, 2.448. Did you verify this one? So you use the equation that was given, 24 times 0.932 equals, with a negative, plus 24.816. So I did it. You guys can try it. I'll give you a minute. Or you can just use your calculators in AOS that I taught you to put it in order of operations from left to right. You should be able to enter the values. Maybe I'll show you that one. So from left to right, 24. .816 minus 0.932 times 24. There you go. So that is the true one. Got it?
Yes, thank you.
And then the last one, let's confirm it's wrong. It would be inappropriate to predict the carbohydrate contents of a cereal with 10 grams of sugar per serving, as there are no cereals in this sample with that amount of sugar.
Sorry, Professor, you're still sharing the calculator screen.
Okay. So the last option, it would be inappropriate to predict the carbohydrate content of a cereal with 10 grams of sugar per serving, as there are no cereals in this sample with that amount of sugar. I don't even see the sample. Oh, that's a problem. So, well, I don't see the sample. I think I had the sample in here, or I thought I did and I lost it, or I can't remember what happened, but the sample isn't appearing. So technically, you can't, this is like, can't even answer this question because you don't have the sample. But the issue is that if the data range is around 10 grams, then you can use the formula or the equation of the line or the least squares regression line to make predictions. If the data is not even close to 10 grams, you shouldn't use 10 in the formula. But you cannot gauge this one because I did not present the data here. So sorry about that. And this is why I let you submit your answers to me, because there might be conflict at some point. But anyway, this for sure is true because I checked it. And E needs to be, I guess, fixed. I need to mention the range of values there. Got it? We're good? I hope. Any other quiz problems? So there, you have the videos that I prepared for the videos from previous classes to review the material. And then I have these documents that I interjected in the notes. Let me look at that. Did you have a chance to see these? Let me see that. Again, back to the notes. So I have all the notes, the discussion and the questions, and then I say, do not worry about studying these. And then I have all these problems, and one of the problems is this one. Okay, so this is also an exercise 4. And how many students got this far? How many of you got this far? We'll put in the chat. Oh, okay. Aleximar wants number 4. I'll go back. I'm looking at the chat. Yeah, I'll go back to that. How many people got this far? And indicate in the chat. Okay, let's this is like a summary of everything on this. Great. Great, Ronaldo. So this is a summary, and we can enter this data and find all these variables using our calculators. Did you guys get that far? I can do it with the calculator. I can do it with Excel. That's the main thing I want to show you. So even though I asked for your opinion, I'm doing the regression. I just want to get this in for sure, because this is a nice summary. Let's do this together. I want you to get your calculators out. And let's do it in the calculator. Those people who did in Excel should get the same answers. The answers follow. I put all the answers here with the formulas. Oh, I put the answers on the platform for this. Let me see again. It's here. Solutions, Excel solutions. Yeah. So overall, there's 2 ways that you might see the data. You may see data like this, right? Where every data point represents one period, and each one provides equal amount of information. In this case, this is historical data, or we call it ex post data, after the fact. The other way of seeing the data would be like this, and I already discussed this in graphing and descriptive statistics, where you could see data that is predictive. In fact, this is a distribution now of data where this outcome for X and this outcome for Y has 40% chance of occurring. This outcome for X and Y have a 50% chance of occurring. And the last one has 10% chance, for a total of 100% of all possible outcomes. So only 3 outcomes, which is, there's an infinite array of things that could happen, but using statistics, historical data, predictive modeling, you can imagine this distribution of outcomes was created. Because this is a distribution of all possible outcomes, it represents the population. And you see, I switch my variables to the Greek letters. Remember, the Greek letters are used for population parameters. And I have all these crazy looking formulas, but they just mimic what you've learned before. Rather than the sample mean, we have what is called the weighted mean. And I taught you that that was also in GDS, in the module 3, previous module 3 on graphing and descriptive statistics. Then the standard deviation would be like this if it's a sample, but this is the standard deviation if you have population level data. This is the covariance if you have a sample, but this is the covariance if you have population level data. It's exactly the same thing. The square deviation from the mean, sorry, in the variance, the square deviation from the mean, but you have to pre-multiply by the weight for every deviation to get the average. Then you take the square root of that, because that was the variance, and you get the standard deviation. This is the covariance. Covariance looks like the variance, but it's more general. I'm going to look at the variability in correlation with, or in concert with the other variable. So I look at the deviation from the mean of X with the deviation from the mean of Y. So I'm doing a covariance rather than a variance, and you have to pre-weigh all of those. So this can be done in Excel very easily. It can't be done on your calculator. So the top one you do in the calculator, or Excel, and the bottom one you can do in Excel. And it looks really bad, but it's not. That's why I took some time to do this. And I actually give you the Excel spreadsheet so you can see the formulas that I create, I think. Yeah, I give you the Excel so you can see all the formulas. If I download it, let's see how it looks. Okay, so with the formulas, I show you how I calculate each of these. I don't know why that's there. So I show how to get the mean step by step with the tables, the variance, the standard deviation, so you can follow what I did with the formula. So you can practice learning here. If I was to give you a problem like this, you can put the values, as long as there's 3, you can replace these, you can copy this sheet and put these values in to get your answer at the end. So it's a step-by-step process that helps you. Or you can do it manually. Anyway, you don't have to worry about this on the exam. I won't give you a question like this on the exam, but it's doable, all right? This is feasible. It's a good assignment question, so I put it as an exercise for assignment to practice. Understanding if the data appears as a distribution rather than like this. So I did all of these too, where I have X and Y, and I calculate and I show you all the formulas in Excel. The average, what did I do here? The variance. It's funny, I didn't use the formula for variance. The standard deviation. So I did it as though you were tabulating, but you also have functions in Excel to get these results right away. And you guys can explore that. So I don't spend, I don't teach you how to use a software per se, because I'm more interested in that you understand how to get these values and to interpret. That's my goal. And I use Excel because after this course, everybody will have Excel on their computer if they ever want to do this calculations themselves. To get out of here, to get the like correlation, there's a function correl. And you would copy, I think you just copy all of this. Something's missing. See, that's why I don't do this. I should be able to just do this and it works.
You have to select X, then comma, then Y.
Oh, it wants the variable name, right? Like this? No. Anyway, see, I don't use this. I just use my calculator in this class. So what were you suggesting I do? X and Y.
I
Yes,
think
you
first the first data set and then comma the second data set. Is that correct, Alejandro?
yes,
Anyway.
exactly.
You guys can look it up. So I have to go
See that
this.
it says array 1, then
Oh, I
comma,
see,
array
array.
2.
Okay. And there, so this is actually the R. So things like that, you can just look them up on Excel if you want to use this. So that's R. The questions I had here was find the mean, the standard deviation, the covariance, the correlation, and the slope and the y-intercept. Those are the types of questions I asked for. So let's do this. This is going to be so much easier with the calculator. And that's why I use the calculator. I mean, once you learn it, it's easy, but it's just time to figure it out. So let's go onto the calculator. And what we're going to do, I need to post the data at the same time. So hold on. Give me a minute. Okay. Okay, so you have the calculator and the data set. And what we're going to do is enter just like we did last class with the mean into the data worksheet. So you hit second data. Now there's something there, so I need to clear that. So you have to hit second clear worksheet and begin entering X and then Y. So you use X here and then Y, and then you go to the next pair. So I enter 0.15, enter, and then I enter the Y, 0.3, enter. And then the second pair, 0.09, enter, scroll down, 0.18, enter. And the third pair, 0.1, enter, and 0.2, enter, and 0.075, enter, down, and 0.15, enter and scroll down. And finally, 0.08, enter, scroll down to the Y, and 0.16, enter, scroll down. Now I have used, I'm going to ask for the two variable statistics. So it's going to look for the relationship between the two. Last time we used this data entry mode, we only asked for information on one variable, but now we're going to get information on two, because what we get when we ask for second statistics are the linear estimates. So it, let me first verify that I entered the right numbers, because I could have made a mistake. So 3. All right. So then I take second stat and I scroll through. And what does N mean?
The number of variables
Number of
or
variables. Very good. Yeah, number of not variables, sorry, observations. Yes.
observation, yeah.
Yeah, I know you meant that. Number of observations. I heard that. Right. And then next, this is
The mean,
a mean of X. Uh-huh. And then
standard deviation,
which standard deviation? The
X.
sample, yeah, of X, right? The sample standard deviation of X.
The sample, yeah.
And then this one.
The population standard deviation.
So if you believe that this is all the data, this is a population set of data, that would be the standard deviation of the population. And now we go to Y, the mean of Y, the sample standard deviation of Y, and the population standard deviation of Y if we believed it was a population of data. And now the regression results, we get A, we get B, and we get R. That is the easiest way to do this, in my opinion. So A is the y-intercept, B is the slope, and R is the direction and strength of the linear relationship between the variables. Perfect. Do you want time to try that yourself? Give you a moment to try it. Confirm you can get these. And on the calculator.
Sorry, Professor. So in exercise 4, when it says utilize the regular mean, standard deviation, and so forth, so the answer will be all the values.
Exactly. I got all of the only one that's missing. If you look here, the only one that's missing is which one?
A.
We got mean, standard deviation, R, B, and oh yeah, A is not here, but yeah, I can make the line as well with the A. So we have that for X and we have it for Y, right? For Y and X. And the only one that's missing out of the calculator is this one. But we can find it. How do we find the covariance if we have this and this? So remember, or if you haven't gotten this far.
You can multiply the R by the...
Yes. So this is another formula you can add here for your purposes, just to remember that you can get the covariance by multiplying the R you get by the two standard deviations that you get. So we can do that when we can get all this data with simple, you agree that was very simple, right? That's the simplest way to solve regression problems of, well, two variables. Now you can do regression for more than 2 variables, but I don't focus on that in this class. There's not enough time. There should be a second course in statistics. I think I don't think there is in this program, but I think in the regular MBA, there's another class in statistics, but there's no time with everything we have to do. So covariance would just be R, S, X, S, Y.
So in the calculator, we just enter the R values, then the,
So I'll show you how I would do it.
okay, thank you.
So what I would do is I would get the 2 S's and I would store them on my calculator. So, or you can copy them on a piece of paper, but it's easier to use your storage key, and you store the first one in 1 and then continue scrolling down to get the Y and store that in 2. So you just hit store 1 and that will automatically put it in the calculator memory. And you know, R is so easy. It's just 1, so I can just copy that down, but I could also put that into store 3. So all my data that I want to multiply is in 1, 2, and 3 storage. I can see the storage by looking at second mem for memory, and I can see that there's nothing in here, but here's the standard deviation of X, standard deviation of Y, and my R. So what I can do to get those values out, so I just taught you a lot. You're fully utilizing the resources of the calculator. To get these data out, I don't know if actually you can do that, but what I do is I use this key here called recall, RCL. Oops, sorry, this key. And I recall the first stored value and I multiply it recall to the second stored value, and then I multiply recall to the third, which I know is a 1, but just to show you. And that is the covariance. So asking you a question like this is suddenly, you know, not so hard to do. It's not so much to expect from you now that you know how to use this tool. So it's in the video if you need to review. This is how you'll get out the covariance. And you want me to do it again? Are you okay?
So when you hit the recall button, you just
The
press
number.
it, and then multiply.
Well, you have to press the number that you want because there's 10 storage slots. So they're
Okay.
all numbered. So you have to recall the number and then times recall number 2 times recall number 3. And there you get it. So you can do this manually. You can write everything by hand, but you can also verify with the calculator very easily.
Got it. Thank you.
So for people who have the calculator, this is the full use of the calculator. The reason I want you to get it. There's also another use that I will show you for the calculator when we get to module 6 and 7. You can any of this you can also do in Excel. It's just a more bigger, you know, clunky process, I think. What I want to say to you is that the first problem in the exercise is better done in the calculator. The second problem, or exercise 5, is better done with Excel. Okay, so you could practice both of those, but don't spend too much time. I'm not going to spend too much, you know, if you see one question like that, that's probably all you'll see. So if you see it, you'll figure it out at the moment when you have the exam, how to do that. The main thing is for people who have the calculator, that's using your calculator. If you don't have the calculator, there's the free version that you can try using. And some of the students with the free version mentioned they couldn't get some data out. How is it now for the free version? Is it working? Can you do this in the free version? Can you perform these calculations? So when we are done, we can get the line. And in this case, the B was 2. The A was 0. And you could also write that as, so why do I have a hat here? This is just my quick overview of statistics, so we can get on to the other review. If you look at this data, if you just stare at the data, what is the relationship between the variables? Just look at the numbers.
Or multiply by 2, something like that.
So they're just doubled, right? Yeah, multiply by 2, multiply by 2, multiply by 2. And that multiply by 2 gives you that slope. So that's the proportional relationship, that the slope is 2. Further, they're multiplied by 2 exactly, making them fall precisely on the same line. What I'm going to do is show you. No, it's on a perfect line. The fact that they're on a perfect line is characterized by the value r. When the observations fall perfectly on a line, r will be 1. If the line is a positive trend, it'll be a positive 1. If the line is on a negative trend, it will be a negative r. Now, this rarely happens, right? This doesn't happen really. What you really have in the end is data that's scattered, or let's scatter it down. That's mostly what you see. In this case, how would I calculate B? I don't see the data. Let's say I just saw this and I estimated the values, and B would be calculated by the formula RSY over SX. So you need to get those statistics. And what would R be? Would R be positive or negative? What is the trend that I see? Negative, right? So R would look negative, but not even close to 1, somewhere between -1 and 0. But not -1 and not 0. Okay. So make sure you do your review. But this is the conclusion. This is like wrapping it all up. This is the conclusion. And we interpret the slope and the intercept. That's the other thing I want you to be able to do. So in the notes, you'll see that with this result, I want you to be able to answer all these questions. So that's what you'll review before the test next week, right? You're going to review or know how to answer all these questions. How to make a scatter plot like I just did. Identify if it's a linear relationship. Is it a positive or negative relationship? What does that mean? Is this relationship weak or strong? The closer the observations are on a line, the stronger the relationship. The closer it is to R of -1 or +1. You're going to get R, and then you're going to use it to make the line. We can do it with the calculator, obviously, but I teach you how to get it manually. Then you interpret the slope and the y-intercept. Then you use the line to make predictions. When you have a value of x, what will y be? And then finding the residual, which is, if you're making a prediction, how far is the real value from that prediction, the actual value versus the predicted value? And then determine if a value or particular value is influential, and then answering the question of the proportion of variation. In other words, calculate R square. That's it. Okay, so I start you, if you never did this before, at least now you know how to get the statistics out of your calculator and then work at understanding all these concepts. That's what your goal is this week, okay? And that's it for that. That's all I want to say about regression. So work on that. Now let's go. We have like an hour left. I'll stay till 11:30. If people have to go, you just go, and I'll leave the recording up for you to finish when you have some time. So let's go into solving. Okay, so we're going to begin with quiz, the last quiz, number 2 of regression, number 4, right, on the quiz. Someone asked for that, and then we'll go to the review. Any questions about what I just said about the regression? Do you know more now than you did at the beginning of class? I hope that helps. Just overview. So what do I want to do? Do I want to go here? Okay, good. This is a different problem. Get rid of the sound. I can't figure it out. Do it this way. Okay, module, sorry, quiz 5.2, number 4. Do heavier cars use more gasoline? To answer this question, a researcher randomly selected 15 cars. He collected data about weight and mileage. From a scatter plot made with the data, a linear model seems appropriate. The equation of the least squares regression line is this one. Oh, I did ask you, what is y hat? Why do we use y hat? Why do we refer to y hat? Um, just back to this for a moment before I do that problem. Although I'm using this line as a prediction line, which is defined as the line closest to all the points, I'm going to use it to make predictions where data doesn't exist. But I don't do that too far away from the range of data. So in mathematics, this line theoretically, or is imagined to go on forever in both directions, but not in statistics. So to differentiate between a statistical line and like a math line that is infinite in both directions, we put a hat. That's what the hat is trying to say. You're predicting in a range of values. You don't predict too far outside. How far you can go, that depends on the kind of data, the theory supporting it, and things like that, okay? Let me make it a little better. Oh, that didn't work. All right. So that's captured by the y hat symbol. Okay. We'll go back to this one. Heavier cars use more gasoline. Okay, the percentage of variation in mileage that is accounted for by the linear regression, by the linear relationship between mileage and weight is approximately 44%. What is the approximate value of the correlation coefficient? So I'll let you read that one, people who haven't had a chance to read it yet, and then I'll tell you the answer. So what did you do? What do you think the answer is?
You just have to take the square root of the 44%, I think.
Okay, and there's one more step. All right, so what you're told is that the information that they give you is that the R square, in other words, the percentage of variation in mileage that is accounted for by the linear relationship between mileage and weight is 44%. So R square is 0.44. Okay, so you need to learn that statement, right? The percentage of they're using a variation on the statement, but basically the variation of Y is explained by X refers to the R square. So R square is just really R squared. So what they did was take R and square it. In other words, if you want to get R, you have to take the square root of R square. Obviously makes sense, right? So I want to take R is 0.44 square, but there's a square root, but there's one more thing I have to do.
The answer has to be negative.
Because
Right. The answer has to be negative because the slope
it's negative.
and R have to have the same sign. If the line is trending positive or up, then the R, the correlation is also considered positive or up, going up. So you lose that when you take the square. You lose that characteristic when you squared it so you need to put it back. So it's like you can take the square root, but don't forget the last step. Put the negative in. So that's the catch. Is that better?
Yes, it is, Professor.
good.
That last step was the one that I forgot to do.
Yeah.
You know, I got the positive, but then I was like, what happened?
What did I
So
do wrong?
I got it now.
Okay, good.
Thank you.
No problem. Yeah, so don't get tricked. So this is going to be negative 0.66. And I have a few problems like that. And it's because output, if you use a stats software, output often comes like this, R square. And if you want the R, you have to remember to do those two things. Take the square root and change the sign because the slope and R have the same sign. Good. All right, so let's look at the review problems. Let's do a few. We can do 2 or 3 of each module, right? Before we go. Or maybe more. I'll stay for another hour. And people, if you have to leave, you just leave and I'll just continue. Well, at least one person needs to be here. Or I'm just gonna go. Otherwise, I'm talking to myself. I need feedback. All right, so let's go into the reviews. Wow, that's showing up. I have to cover it. It's weird. Okay, let's see. Review 1. Can you suggest to me any ones that you want to look at? Or you want me to pick?
I had a question about number 2.
Mm-hmm. Okay, I'll let everyone look at it for a moment while yeah, so look at that. Give you a few minutes. All right, let's look at this. Okay, so this is kind of challenging. The distribution of weekly salaries. Sorry, let me get the distribution of weekly salaries in a small company with 19 employees is such that the first quartile is 500, the third quartile is 1100, and the range is 1000. From this distribution, the distribution of salaries necessarily satisfies one of the following statements. Which one? Okay. Okay, given this information, do you have anything here that you can get from the mean and standard deviation? Can you get the mean and standard deviation from the information given? N is 19. First quartile is 500. Third is 1100, and the range is that. So this is the information you have. And, the properties of Q1 and Q3, the first 25% of the data is marked by, the Q1 marks all 25% of data are below it. Between Q1 and Q3 is 50% of the data. And then between the max and the Q3 are 25% of the data. Do we know anything here about mean and standard deviation? So by process of elimination, since this doesn't give us any information on mean and standard deviation, I'm going to omit B, C, and D. So we're down to A and E. Does everybody agree? And wouldn't that be nice? So we're only looking at A or D, or E, sorry. So A says the median is 800. Can I know the median is 800 from that information? So again, process of elimination, because it's, you can't calculate those things. Its median is 800. How do we calculate median? Let's remember median is where at the n+1 over second observation, but I can't get it. So you're down to looking at E. Is the answer E?
I guess it has to be,
It
but
has
my
to be,
question,
but how? Right?
but the thing that I'm a bit confused because it says maximum between 1,100, but can maximum be the same as the third quartile? That doesn't
Yes.
sound right to me.
Yes, it can, because all the values could repeat. So that's what's being emphasized here. Your data could look like, so what is this again? This is salaries, weekly salaries. So the weekly salaries could all be the same, right? So if my data was like, so let's say, actually, let me write it like, So you could have like the weekly salary is 1,000, 1,000. It could happen, right? So yeah, that's the catch, is it's making you realize that they could all be the same number. But wait, what is it? Between 1,100, sorry, let me make it 1,100, so it looks. They could all be 1,100. That's fine. You might have a lot of employees with the same pay scale. So it's not a far stretch to imagine that. It's just weird because you're used to the numbers being different. So the maximum is between 110 and 1,500, where the Q3 is 1,100. Sorry, not 110, 1,100. Now, why do they say 1,500? So if, okay, so the range is between, so if the range is 1,000, yeah. It's 1,000, and that means the max minus the min is 1,000. If you could make the max 1,100 and the min, so this is if the min was also the same as Q1. This is the I don't want to confuse you. But okay, so let's say Q3 was also the max and Q1 was also the min. This is the smallest the range could be. I mean, this is the smallest, yeah, the range could be. But it tells you that the range is 1,000. But this would make the range 900. No, what did I do? It's not 900. How much is that? 600. So it tells you that the range is 1,000. So they're not both going to be max and min. So one of them is not, or at least, right? So, the maximum is between 1,100 and 1,500. Anyway, by elimination, by the process of elimination, you're down to E, and E is feasible. Because if both of them were max or min, it can't be because it has to be 1,000, but
Yeah, I
it's
think I
feasible.
understand. Sorry to interrupt. I think I understand, because if the first quartile is the same as the minimum, then the maximum would be 1,500 to get the range of 1,000. But if the third quartile is the same as the maximum, then the maximum would be 1,100, excuse me.
Right.
Yeah, and I think I understand that part.
So the point was to realize what you cannot do here. Okay, so none of these, the information does not give you enough to calculate A through D. So the maximum could include 1,100 as far as 1,500. And the reason why they say 1,500 is because the range has to be 1,000, and if the range is equal to 1,000, then the max minus Q1 would be 1,500 minus 500, which is 1,000, and that's feasible. So it's showing you a minimum for the maximum value. It's showing you an extreme for the maximum value. The most that it could be is 1,500, and the smallest it can be is 1,100, and all you're doing is trading off whether Q1 is the min or if Q3 is the max. Those are the options, 1,100 to 1,500. I think that's the best way to summarize that. Okay, and you would have got, without doing that extra step, you would have eliminated A through D if you knew what you were doing. All right, let's do another one. Which other one next? Should we do this one? Okay, so first step is to put the data in order. Okay, so take that first step, put the data in order. So I'll give you a few minutes.
Professor, that's not data, that's a 5-number summary, isn't it?
Yes, you're right. I didn't read that. That's an error in reading. Yeah, that's a 5-number summary. So the data is already put in order. You have the 5-number summary, and now identify the outliers. Sorry about that. Okay, let's see. Okay, I'm gonna make an outlier box plot. And I have to compute the limits. So I'm gonna take Q1 minus 1.5 times IQR. I have to actually calculate IQR too. And Q3 plus 1.5 times IQR. Not sure why I have brackets there. Well, anyway, I'll put the bracket. And IQR is Q3 minus Q1, which is 24, minus 19, which is 5. Q1 is 19. Q3 is 24. And now I'm going to subtract 1.5 times 5. And here I'm going to add 1.5 times 5. And what do I get? If anyone has trouble with the calculator, please contact me. If you don't get the answers I'm getting, your calculator might not be in the order of operation mode. So just let me know if that happens to you, that you're not getting the same answers as me. All right, are we getting the same answers? I did something wrong already. 19 minus 1.5 times 5, 11.5. Shouldn't talk and calculate at the same time. 11.5 and 24. I think I multiplied rather than added. 1.5 times 5. 1.5. Okay. And then and that's it.
Why we are subtracting the 1.5 from the Q1 and adding the from the Q3?
So the idea is we make a box between Q3 and Q1. Q2 is in there. And then we're going to extend the box. I have to make it smaller. Then what I'm going to do is this represents the middle half of the data. That's how spread out it is. And in terms of statistics and the idea of relative measures, right? So statistics is about averages and relative measures. So we're going to use this range, interquartile range, to tell us what's kind of regular about the data. And we're going to say, we're going to take that width, which is the IQR, and extend it by 1.5 and do the same. Any values that go as far as that and a little bit more. So we're going to take IQR and multiply. So this is 1.5 times IQR this way. And we're going to do the same thing on the other side.
Okay, got it. That's
Got
why
it?
minus.
That's why.
Yep.
Usually we only do it on one side because we only see it on one side. But we're going to check both sides. But we don't have the data, right? So we don't have the data. This is just a rough look. So we go a little bit bigger than a little longer than the actual range to find the data, and that's how we get those numbers. And so the answer is, looks like, in the chat, you guys can put your answer.
Well, it's everything that is below Q1 and above Q3. I mean, the calculations that we did.
Yeah, the calculations with Q1 minus 1.5 times IQR and Q3 plus. It's always, yeah, forgetting that you have to check both. Usually we just check the side where we see the spread. Now below 11, let me just check if there's a catch in this problem before we look at the answer. If someone can tell me the answer. So both of these values, so this is, so you have, so you can tell already there's at least one outlier. Which one is it?
Ten.
At least, yeah, exactly. We don't have all the data, so don't get tricked, but at least we know that 10 is here. There could be more because I don't have the data, but 10 is there. And on the other side, we don't see anything outside, but at least there's an outlier here. And that's how the outlier box plot is done. There's a couple of variations of the outlier box plot, but essentially, it just shows, it marks the position where, you know, everything sticks out. So we know at least one outlier exists. It didn't ask you that, but we can see that. This 10 is at least one value. Good. Okay, let's continue. Anyone has a particular one? Let me know. 6, we did something like that, or no, somebody send me that question. Median. What about 6? So in the class, we did something about, last class, we worked with some data about the weight or the height, I can't remember what it was, in the classroom of students, and one student leaves and you've recalculated the new mean. In the case of the median, you actually need the data. You can't just make a bunch of calculations. If you don't have the data, you can't sort this out. You just know the median age is 30 and someone who's 50 leaves. You have no idea without seeing the data how to answer this. So the answer to 6 is D. Is everyone okay with that? Think about that.
Yeah, I think that the catch in here was reading correctly, and in my case, I was when I did the problem, I didn't take it easy and thought about the median, the mean. Sorry.
Yeah, exactly.
So I was like, yeah, and then after trying to solve it, I was like, yeah, the answer is actually in there, I think.
You can't do it without the data. For the median, you need to see the data.
Yeah, and if you calculate the mean, I think the answer is 25.
If you calculate the mean, oh, if you use the same technique that we did before, yeah.
Yeah, and then that's the catch.
That's the catch. Yeah, the trick. Yeah, no, it's median is a whole different thing. That's right. Well, just tell me which one you want to look at. You guys can tell me in the chat. What about this number 7?
Sorry, so the answer was the not able to determine?
Yes,
or
D.
Okay.
D. Yeah, should be
Okay,
D.
got it. Thank you.
Yeah. What about 7? Again, if you guys have to go, you can go, but I'll stay till 11:30 and I'll do a little bit of each. So let's do one more in this topic, because we still have to look at module 2, right? we have a lot to do. So let's look at this one and then we'll go to the next one. We'll go to the next module.
Can we see also 14 of this one, please?
Sure, sure.
Okay.
Well, you guys, you want to do this one? Some data on a variable X was gathered from which the following histogram was obtained. Also displayed is a density curve that approximates the histogram fairly well. Okay, so they smoothed it out. Which of the following statements about the distribution of X is false? The mean is approximately 1.25. That looks, that makes sense. 1.2, approximately 1. Yeah, because it's 1.4, it's going up by 1, 2, 3, 4. Okay. So it's going up by 0.1. So it's about, yeah, between 1.2 and 1.3. So yeah, A is true. The range is approximately 1.1. How do I calculate the range? I have to go between max and min. The max is like a little more than 1.8 and the min looks like 1.7. So, okay, yeah, the range is about, so B is okay. The range is approximately 1.1. C, the distribution could be approximated quite well with a normal curve. What do you guys think? True or false?
That
False.
one. C is possible. Yeah.
It's false because the normal curve has one peak, not two. That's basically what they're getting at here. The normal curve is a symmetric curve that's spread out in a particular way with 68% of the observations within one standard deviation of the mean. That's not going to happen here at all, right? If you look at it, if the mean is 1.25, like I can't. Anyway, right in the middle there, the drop, if you go one standard deviation away, you're not catching it's a very little data there. But anyway, also a normal distribution is peaked in one place, not in two. So this is a bimodal distribution and it's not normal. What about the other options? It would seem there are two different groups of values for X. Smaller values. Anyway, sure, that's true. And then the distribution is approximately symmetric. It is symmetric, but it's not single peaked. A normal distribution has one peak. Okay, so the problem is C. That's false. All right, now somebody asked me for, which one? 17? What did you say?
So, Professor, before we skip that one, that question, I have a question. If we get a question like that one, and we say one of the reasons why we say it's C and we say it's unimodal, but there's also other reasons why it's false. Would we get all the points or not?
So, okay, so if you picked C, but you also argued that something else is false,
No, no,
I
what I'm
might,
trying.
yeah, I might give you half the marks, like half of the points. But if you only have to pick one, just pick one. But if you feel like I made a mistake, because sometimes, you know, you can debate some of my choices, you can argue. But yeah, I probably, in that case, I wouldn't take points off if I actually made a mistake. But if it's clear and you argue and defend a second point.
That's not what I meant. What I meant is like if the it's unimodal and it's also that the thing you explained about the mean, that the mean is also wrong. I don't quite know how to explain that. If we just say it's unimodal and we pick C, would that still count? If we even
So
if
if
we
the
don't
picture
say
was like
each and
this
every
and you pick C, you're saying if the picture looked like this and you pick C?
No, what I'm trying to say is if we picked C and the graph is the same way as it is, that the exercise is correct, but we don't give every explanation about why C is the correct answer, would we get all the points?
Oh, so if you you just have to defend your answer. You don't have to go through each one and
Okay,
critique like
perfect.
I did. That's what you want to know. Yeah. Just defend your answer.
Thank you.
If to make your argument, you need to refute the other ones, then you should do that. But in this one, no. If it's enough to just defend here, you just defend your answer. So it's enough to say that, yeah. If you feel uncertain, put everything you can in your answer. Okay, what was the other question you asked me for? 9, 10. Someone asked me to do one. Oh, number 7. In this board paper for the test, you have to explain verbally our selection.
That's the same question that you was just brought up. So I think I have the response.
Okay, yeah. But somebody else asked me for something, and I
14.
okay. Okay, so 14 is now normal distribution. The World Health Organization study of various countries reported that North Americans have a mean of 121 for blood pressure. If their blood pressure in North America has a normal distribution and Bill is told that 2.5% of the population has a systolic blood pressure higher than his, then the standard deviation, okay, so this one, so you're told that blood pressure has a mean of 121, but they don't tell you the standard deviation. However, Bill has a blood pressure that's that 2.5% of population has a blood pressure higher than him. So you found out one value, and that value, so if I was to put 2.5 that he 2.5% of the population has a systolic blood pressure higher than that. So if we imagine here on this curve that you have all blood pressures and 2.5% higher, every time I write area under the curve, I use 4 decimal places to remind myself that that's inside the table. And this is the X that we're given. This is Bill. Okay. And we want to find out the value for Bill. And this would be the distribution for X. This would be the distribution of X. However, we learn about the standard deviation to help us figure this out, because we know intimately all about this, the standard deviation, or the standard normal curve. Sorry, that's what I was trying to say, the standard normal curve. So the standard normal curve looks similar, right? And it has a mean of 0 and a standard deviation of 1. And if I look to see 0.02500, I just need 1 0. I don't know why I put so many zeros. I have to put 4 zeros. I can find the Z that corresponds. And then I convert back to Bill's blood pressure, which is 121. They told us 121. In this problem, it's a little different than the kind of problems that I solve, because I'm giving you here, I give you the X, but I want you to find sigma, but you do the same backward technique, okay? You don't do anything different until the end. So what do? First, I use the Z standard normal distribution to find the value such that in other words, how many standard deviations do I have to be from the mean to have 2.5% of the observations above? So you need to go inside the table and get me the value. If you look inside to look for this number, you're going to find a negative value. The alternative is to look inside for this value, 0.9750. So there's two ways you can do it. You can look up this value or this value. Just remember that the Z-score you get needs to be positive because on the picture it's here. So I always tell students to draw them so they don't mess up. So let's get the table up here. And talk about the table. So if I go on this side of the table, I look for 97975. There it is. Nice. Right there. 975, right? So it's 1.96. Is everybody okay with that? If I looked up the number 0.025, I would have to use the negative table. .025. Be careful with all the zeros. You want 0.025. 0.025. It's perfectly right here. You see that? And also it's 1.96, but it's negative. It's negative because it is assuming you're going for this one. So just be careful with the tables that if you're doing the upper tail, you have to change the sign, right? So if you're changing the direction, you're changing the sign as well. If you're going this way, this is all because of the symmetry of the normal distribution. So the answer is, back to our sketch, the answer is 1.96 standard deviations. You can look it up either way, but don't mess it up with the sign. And then in the second step, so this is where things change. What you want to find is X equals Z standard deviations from the mean. X you have. Z you have. Sigma you don't have, but you have the mean. Oh wait, what did I screw up? Bill was 153. I wrote the wrong thing. Bill was 153. You guys didn't stop me. Sorry. Bill's 153 and the general is 121, right? So that mean is 121. And this, and honestly, this is where students, they don't know where to put the numbers, but I read it wrong. So this is Bill 153. Is everybody okay with that? So Bill is the X. He's one value. In general, the mean is 121. And that he is positioned almost 2 standard deviations above the others. So now you can solve for sigma. I'll let you do it. Sorry about putting the wrong number there. So to do the algebra, all in one step. What do you get? The answer is 16. It's A, right? Should I do the algebra slower, or are you okay with the algebra?
We're good. At least
Yeah?
we-
Okay.
Yeah.
Thank you. All right, so let's do one more normal. And then maybe we can do a couple of regressions and go. But again, if you have to go, just go ahead. I'll just finish doing a few of these. One more normal. So this is an example of the backward problem. Except I call it a backward problem with a twist. You're looking for something other than X. You're looking for sigma. So the last step is to unravel and find the missing value. But it's the same technique. Not too many normal ones. Okay, which one would you like?
Professor, I would like to see the 19.
Okay, do you want me to do another normal, or you want me just to go to regression? If everybody's okay, anyone want another normal?
16?
A normal?
Yes.
Okay, let's do one more normal and then we can do 19. Let's do, you want to do another backwards one, or you want to do 17? So you want to do 16, 17, or 18? Which one do you want?
16.
16. Okay. The house prices in a certain neighborhood are normally distributed with a mean of 150,000 and a standard deviation of 24,000. The proportion of houses for which the price exceeds, okay, so the P for proportion of houses whose price, so that's representing X is the price of houses. The P is for proportion exceeding 120,000 is equal to what? So what we do, because we know the standard normal so intimately, we convert this to standard normal so we can use our tables. And the way we do that is we take 120 we minus the mean and divide by the standard deviation. So in the end, we get 120 minus 150 divided by 24. So what is that value? And 2150 by 24.
Negative 1.25, I think.
With a negative, right? Don't miss the negative. Then we draw this. And how do I draw it? Where do I put my mark? 0 is in the middle, where this is the z. 0 is in the middle. So I draw negative 1.5 this way, and I press my arrow that way. I have to follow whatever this is. I have to go in that direction, right? And I have to plot this with 0 in the middle. That means it's over here. Now, remembering that the tables and Excel only give me the left side, but I want the right side. So if I look this up in the table, I will get this, which is fine, but I'm not finished yet. That's not my answer. So let's get the table and look for negative 1.25. I'm looking, it's the z-score that I'm given. So negative 1.25 puts me over here. 1056, 10.56%. So this is, but that's the left side. So what I have to do is find 1 minus 1056 to find my answer that I want. So that's why I encourage always make the drawings. Right? If you don't, like, some students just get in the habit of calculating this and looking in the table, but you can't do that. You have to know which direction you're looking and what you have. So one
Professor,
minus,
sorry.
Go ahead.
No, I was going to ask, I follow the negative 1.2,
Yeah,
but I'm not following the,
the 5.
yeah.
Okay, let's go back. So here is the negative 1.2, but then the second decimal is here, 5. So you find
Oh,
the-
got it.
Got
Yeah,
it?
okay.
Thank you for
Got it.
asking.
Okay.
Okay. And that, but what you have in the end was this side. That's not the final answer. So then you have to take 1 minus to get this answer. And is that option there?
Yes, the C letter.
It's there. And it's C. The other thing you can do is when you have a negative, well, again, let me repeat that. If you change the sign and the direction, you are going to get the same answer. This is also equal to P Z less than 1.25. So I change the sign and the direction. So I can actually look this up in the tables and I will get the same answer. Let me show you 1.25. I have to go to the positive table. And look, if I look at 1.25, the answer is right there. Okay, so changing the sign and direction will give you the same answer. You can also do this in Excel. Do you want me to show you that, or do you know how? I can do
I'm-
the last two problems. I'll do them both in Excel. I'll show you, okay? The last two problems that we did. So let's do this one first, because this one is fresh as in our mind. And I'm gonna just do it on my computer. It's just so different on the iPad. I unnecessarily delay things when I do it there. All right, so I'm gonna flash you my Excel. So for the one that we just did, I put the equal sign. I put norm. And again, this is a way to check your work, right? You can verify. And I don't mind if you use Excel, of course, but you have to write it down to show me your work on the test. So you have to do both. So now which one do I pick to do this problem? Do I pick distribution, inverse, standard normal distribution, standard normal inverse? I'm going to pick this one. And if I pick this one, let me check the chat. Hold on. Oh, no, sorry. All right, let me put them in first and then I'll check the chat. So I have to put X. What's X? If I use this, what's X? Let me flash again what I did. So what is X in this problem here? X was up here, 120000. We can go right from the beginning to get the answer from Excel. The only catch is that in Excel, it only gives you the left side. So you have to remember what you're getting. So if I put 1,200, what did I say? 120,000. If I put a 120,000 onto Excel, then which mean do I use? Well, what was the mean in the problem? It was 150. And the standard deviation was 24. Remember from the very beginning. And then I have to ask it to be cumulative. So it gives me the left side cumulative true. So with that, it will give me the left side probability. Remember this number? That's the formula. So am I finished? You still need to know, even if you use Excel, you need to remember that is only giving you the left side, but you want to go greater than that. So you have to take equals 1 minus this left side to get the answer. But that's how you use Excel for that one. So some people might think it's easier. Some people might feel like, oh, I'd rather draw it. So this leaves you, options. You guys can do whatever you like. I could also answer this question using a different function. I could use this one with the standard normal. Now, if I use this one, I have to have the z already. So what number do I put there? What was the z that we found? The z-score. Let's go back and look.
0.25, I think.
That's right. Let's look again. It's negative. Don't forget the negative 1.25. Okay, so you can do it with the z-score. You need to know what you have. So just saying you're going to use Excel is not enough. You have to know how to use it, right? So negative 125. So I'm going to put negative 125, but I have to remember that Excel only gives me the left side. And then I put cumulative, so it gives me that left side. And I still have to do the 1 minus no matter what. Let me show you the different formulas. You can stare at them. The one has the S, so that makes you put the standard normal result, the Z, in there. This one is right from the original problem. You can solve it, but it will only give you the left side. There. Remembering Excel is just a reference. You have to reference the cells you want to compute from. And the way you find the reference number is touching the cell. It will tell you here where you are. All right, what about the other one that we did? So the one, I'm going to go back. Oh yeah, let's do the, okay, so I'm going to go back. Remember Bill? Let's go back and see if we can solve the problem for Bill and his blood pressure. Let me show you that again to remember. All right, so in this problem, I have the inverse problem or the backward problem. These were all the values. We have X was 153 and sigma was what we're trying to find. Actually, I don't know that we can do this one for sigma. We can find, yeah, I think we cannot do this now that I think of it. Mu we have. Yeah, because the inverse problem will just find X for us. So we actually cannot do this one in Excel, which is interesting. You will have to
Now,
do this. Mhm.
Professor, now that you are there, so I get a little bit confused when you were doing the sigma calculation that you get the 16.3. So I know that.
I can do it again.
Thank you.
Yeah, because I just jumped. So to do this calculation, so just to repeat, you can't do this in Excel because Excel would only solve X. It won't solve sigma. So let you know the limitations of Excel. So here, so we're here, 153. Let me erase this red line. So for algebra here, I'm going to combine my terms, the constant 153 and 121, I want to put them together on one side. So I'm going to subtract both sides by 121. So that I get 32 equals 1.96 sigma. So then sigma is 32 over 1.96. That's it there. And it's 16. Or 16, yeah. All right. So that was it. It was just that I combined these two, subtracting both sides. That's how I got that one.
Okay, I think it was my calculator that wasn't in the correct mode. Thank
Okay.
you.
Okay, is it okay now? Do you have it in the right mode?
Yes.
Okay.
Yeah.
All right. All right. So if it was a backward problem when you were looking for X, you could use Excel. And you would pick equals norm, and you would norm, and you would use either this inverse function that will return the value of X if you give it the probability. It asks for the probability, you see, and the mean and standard deviation. But our problem, we're not looking for X, we're looking for sigma. So there's no formula for that in Excel. Just to keep you clear. So if you did it using the standard normal inverse, all you have to give is the probability, and it will give you back the value of Z in this case for the standard normal S. So draw these things, draw them so that you can see what you're doing and not just be automated in answering questions. There's like 5 types of problems. I explain this in the lecture. There's 5 types of problems, and there are 2 that are concerned with calculating the probability. And then, so those are the type 1 problems. And then, so given a value of X or given a value of Z, find the probability if they're distributed normal. The type 2 problem is I give you a probability and you find me the Z score or the value of X. Okay, so those are the problems. And then I also say there's other types of problems that just have to do with theory about the normal distribution, or these problems with the twist on them that we just did here. All right, let's see. Yes, Damari says, are we going to continue to review? Yes, that's what we're going to do next class. Yeah, before the exam, we're going to continue with the review. So bring all your problems to me, right? Aleximar, did you have a question? You had a comment, I didn't see it till now, about the standard. The standard, right. I hope you're here still. So should we do 2 regression ones and then we'll get off? It's going to be 12. I mean, it's fine for me, but we'll do 2 for regression. Someone asked me to do 19. Okay. So you're okay, Aleximar? Aleximar, I'm not sure if I'm saying your name right. Okay, so let's go back to my iPad. And let's look at 19. We didn't do anything with the, so next class, what I'll do is I'll start with the module 2 questions because I didn't do any today. So we have 3 scatter plots. without looking at the options, let's just look at the scatter plots together. In the first scatter plot, what would be the R approximately for the first scatter plot that you have like that? What would the R be? Positive or negative?
Negative, positive, negative.
It's negative? And it would be close to 1? Would you agree? So the observations are close on a line, but not exactly. So if that's true, which of the options are good? Is A good? B? No. So those are both positive,
C.
so those are out. So C,
C and D.
C and D look good. So we're down to C and D. Process of elimination for A. So let's look at B. B is a little more scattered. Something like that. Positive or negative?
Positive.
And it's close to 1, but not so much as A, right? Right? So relatively speaking, let me make this bigger. So it's less close to 1 than A is. So which options work?
C.
Yeah.
So let's see. So it's positive, so it can't be A. It can be, but it's closer to 1. It's not 0.02, that's close to 0. So C could be good, or E, right? Do you agree?
Yeah.
The same number. So just by what we've done, look, we already know the answer. Because for A, it has to be C or D. And for B, it has to be C or E. And the only one that is consistent is C. So the answer should be C. But let's look at the last one. In the last scatter plot, that looks something like this, and it's all scattered around. This one should be maybe a little positive, but close to 0. Does everybody agree? I say it's positive just because of this point. It's very, very, very close to 0. It's very flat, but just a little bit positive because of that last point towards the end. That one I can't show you because let's see if I touch it. Anyway, right under here. I can't touch the picture. Anyway, towards the end. So C is the answer. You see that? So it's C. Another one, it could be A or C, but because they have to all be the same, it's C, C, and C. So the answer is C. How did that go? That's not so hard? Does everybody know why I'm saying it's positive or negative? It's positive or negative depending on the trend. And I explain this in the videos, how you can think about that. When it's flat like this, it's close to 0. No real trend. It's just slightly positive because there's that one number, like just like that. Pulls it up a bit. Okay, one more regression. And we will go. Which one would you like to do?
Professor, just a question. In the case we have questions in the exam like the 19, we don't have to go so deeply into an explanation, right?
Well, just like this, what I did here is
Yeah.
fine.
Yeah, as we take some notes so you see where we get the results from.
Yeah, just like something like that. Just kind of showing me, you don't have to write an essay. Just show me
Okay.
your thinking process, you know?
Okay. That's good. Thank you.
Yeah. Shall we do a calculation, one with calculations? See if there's a residual. The homework is really good for regression. Make sure you do the homework exercises. Okay, let's look at 24. Try that one. Okay, what do I do? How do I get the equation of the least squares regression line? And there's some steps, right? First, X bar, Y bar is on the line. What's X bar, Y bar? Do I have that information? Which is X and which is Y to begin with? Which variable? Students mess this up. Identifying X and Y.
X will be the milks, the cup of milk,
Right,
and Y will be the height.
right. So I know that because it says the height of children versus their milk consumption. When I have a versus, it's always y against x, okay? It's always y against x. So that's how I know height is y and milk is x. And you wouldn't believe me unless I show you, but students mess that up. So don't mess that up. So I always tell you, I give you a hint, or it's not exactly a hint, but I'm trying to tell you what the graph looks like without putting the graph right in front of you. All right, so that means that x bar, which one is x bar then?
$6.5.
6.5.
Very good. And which one is y bar?
That's 1.2.
Mm-mm.
Ah, sorry. 60 inches.
Mm-hmm. Everybody see that? It's in the bullets. It's given to you. Okay. So I have that. Next. The slope. So if I have a point,
Yeah, you need to calculate the B using R and the
exactly. So I have to use everything to get my slope.
Yep.
So this is the formula that I give to you. And you have to, know where to get it or write it on, create a list of formulas for yourself. Or remember this mnemonic here that I show the students. It's R and it's a ratio of SY divided by SX. Because the slope in finance, when you use financial data with the example that I showed you at the beginning of the class, exercise 4, the interpretation of the slope is a sensitivity of stock returns to market performance returns. So anyway, that's how you calculate it. So let's pull out the information. R is given, is it? Correlation is? What does it say?
0.9.
Very good, 0.9. And SY, be careful, Y is height.
That's 1.2.
There's your 1.2. And cups of milk standard deviation, 3.6. Now, put it all together,
0.3.
0.3. Everyone agree? I get 0.3 as well. And so it's a positive, so I don't even have to do anything else really, right? If I believe I did everything correctly, which is my answer?
C.
You know right away, answer is C, but let's finish it. Okay, answer is C because that's the only one with a slope of positive 0.3. Now, the only thing that would have made this a negative is the R, right? The slope and the R are the same sign. I think I mentioned this last class because these are both positive. Maybe I didn't because I must have it in the videos because we didn't talk about this last class. I'm thinking about my other class. Okay, so the answer is C, but let's finish. So to finish this, the third step is to put in to the equation of a line everything you have. Now, we have the slope as B. And for the point, we're going to use X bar, Y bar that we extracted from the information. And so I'm going to put Y bar is 60. So 1 point should satisfy the line. A, I don't have. That's what I need to find. 0.3 for B. And X is going to be 6.5. And so I have to do the algebra here to find the A. 1.95. So A is equal to 58.05. And now you can confirm for yourself. The answer is C. So we write y hat equals 58.05 plus 0.3x. And that is that. So I know I make it look easy, but you guys can get here with practice. You have my resources. You have me too. If you get stuck, I've had students send me problems and I've corrected them and sent them back. So if you no need to be stuck. Just give yourself a fair amount of time to practice. If it's obvious you haven't practiced anything and you want me to help you, just show you and teach you everything, I probably won't do that. But if you give me a problem that you've started and you're not sure how to finish it, I can finish it for you and send it back to you. Okay? Or I can meet with you virtually if you need to this week at a mutually convenient time before the test. We will meet next week and we will continue the review. So bring me all your questions. And then you will have the 3 days to work on the final, or the test. We're not at the final yet.
Perfect.
So thank you for staying and keeping me awake. And alert and correcting me. I appreciate it. Anything you find in the notes that's confusing or you think it's an error, just don't hesitate to let me know. And hopefully I pray you find the time this week to study as much as you wish to, and you're prepared for next week for our discussion, all right? So we'll see you next week. Unless you want to contact me before, I'm available.
Thank you, Professor.
Thank you. Bye.
Bye-bye.
Thanks, Professor. Bye-bye.
Bye.